Alright, so let's look at another system, not a square system. So the one we did before was a 3 by 3, I think, system. 3 equations, 3 variables. Don't get confused that, the matrix is not square. What I'm talking about is how many equations versus how many variables. So this is a rectangular system. It's what we call an underdetermined system. In other words, there are four variables that we need to know, but there are only 3 equations. Okay, and so that's going to give us an augmented matrix that looks like that. Let's just show you how to put this in row-reduced echelon form. We're not doing anything different, but sometimes you feel a little different when not everything looks the same, or when it's not a square matrix. So we're going to start right at the beginning. We don't have to swap any rows because we have a 1 in that first upper left position, so it's good to go. All right, and so we're just going to want to zero out these two terms. So we're going to do that here. Let's go -1 times row 1, add to row 2, replace row 2. So -1, -1, -1, -1, -12. Row 2 is a 1, 2, 0, 5, 17. 0, 1, -1, 4, and a 5. Since we're on live TV, hope we don't make a mistake. But that will be our new row 2. Excuse me. And so to get our new row 3, we're going to go -3 times row 1 plus row 3, replace row 3. So -3 times that is a -3, -3, -3, -3, -36. Row 3 is a 3, 2, 4, -1, 31. 0, -1, 1, -4, and a -5. That will become our new row 3. And at this point we do need to write down an equivalent matrix. So 1, 1, 1, 1, 12. New row 2, 0, 1, -1, 4, and 5. And new row 3. Okay, we got our first two zeros, right? We're doing the Gaussian elimination, eliminating things below leading terms. So once you've got a leading term and zeros below it, then you move down one row and over until you hit a non-zero term, and that's going to be your leading term. Now you want to zero things out below that, so we're just going to zero out that -1. Pretty straightforward there. It's going to be row 2 plus row 3, replace row 3. Row 2, row 3, looking like that. Did we get that right? Yes, so 0, 0, 0, 0, 0. Alright, that's going to be our new row 3. Alright, a lot of zeros. That's okay. Row 2. And row 3. Okay, so we've zeroed out everything below our 2 leading terms. We've got our zeros below. And now we want to move up. There are no more leading terms, right? This bottom row has no non-zero entries to be candidates for leading terms. So now we want to move up and eliminate anything above the leading term. So that is only this. That's the only thing, non-zero thing, value above a leading term. So this is the process that you go through to get it in row-reduced echelon form. So we need to eliminate that green one. So we're going to take let's go -1 times row 2. Remember, technically what we do is we multiply the row that we're not replacing. So we're multiplying row 2, -1 times row 2 plus row 1, and replace row 1. So -1 times row 2, 0, -1, 1, -4, -5. Row 1, we add them, we get this. Okay, and so that gives us new row 1, new row 2, or same row 2 I guess, and row 3 is all zeros. And there it is. That is our matrix in row reduced echelon form. Okay, now we're going to, at this point, we're going to need to find the solutions, right? And remember our rule: these two things, any column that has a leading term in it, those two have a leading term. Okay, the other columns don't have a leading term. These are our free variables, right? The columns without leading terms, the x sub 3 column, oh, there's not an x sub 5 column. The x sub 3 column and the x sub 4 column are both free variables. And so the way we do this, we know we're going to have an infinite number of solutions. And so if you have, basically if you have any free terms or free variables, you're going to have an infinite number of solutions. All right, so that means we're going to go into this mode. We're going to say, okay, x sub 3 will just let be s, x sub 4 will let equal t. And now we need to write, so they are free to be anything they want. Now we need to write x sub 1 and x sub 2 in terms of those. So the way that looks, we take the first row, and if we translate that first row into an equation, it's 1x sub 1 plus 2x sub 3 minus 3x sub 4 equals 7, right? So if I solve for x sub 1 and substitute in what I get, what x sub 3 in, x sub 3 is s, right? X sub 3 is s and x sub 4 is t. Then here is the expression for x sub 1. 7 minus 2x sub 3 plus 3x sub 4. Okay. Why don't I make the substitution you're asking? Good question. Minus 2s plus 3t. Okay, so we want to keep track of that, and that. And that was from the first equation. Now if we take this first row, the second row is going to become this, right? X sub 2 minus x sub 3 plus 4x sub 4 equals 5. And if we solve for x sub 2 and replace x sub 3 and x sub 4, we're going to have 5 plus s minus 4t. 5 plus s minus 4t. And so our solution, if we write it nice and clean, x sub 1 is 7 minus 2s plus 3t. X sub 2 is 5 plus s minus 4t. X sub 3 is s. And x sub 4 is t. And so we are free to choose s and t to be anything we want, and we have can then determine what the other variables are going to be, and that gives us one of the infinite number of solutions. Okay, so that's a process of putting this matrix, another example of putting a matrix in row reduced echelon form. Now I want to show you how to do this on technology. Okay, let's take a look first at the TI calculator. I know that's kind of small. Hopefully you can blow that up on your screen. Let me just make sure. I'm looking for my, yeah, that's as big as it gets. So how do you use a calculator to do these things with matrices? Now let me be clear. When we take a matrix and put it in row reduced echelon form, you know the drill, right? You're a math teacher. We want our students, and I want you to be able to do these things by hand, right? I want you to be able to do them and understand how to do them by hand. But once we get comfortable with that, we want to move on and let the technology do this hard and tedious work for us so that we can answer bigger and better questions. So make sure you can do these things by hand. Even though your calculator can do them, make sure you understand how to do them by hand. So what we're going to do is we're going to want to enter our matrix into the calculator. So we go to this matrix button. Hopefully you're seeing everything here. And I've got the names of several matrices. I want to edit, and I'll edit A, matrix A. So I hit enter. So here I'm going to enter my matrix. So we're going to enter the matrix that we just used. So we enter the size. Ours is a 3 by 5, the one we just played with. And so that creates a matrix of zeros. And so what we need to do is enter the matrix. 1, 1, 1, 1, 12. Okay. 1, 2, 0, 5, 17, and 3, 2, 4, negative 1, so make sure you use the negative, negative 1, and 31. Enter. And now my matrix should be there. Now it's really important that you do this next step. You need to quit this matrix entering application, or whatever you want to call it. So we're going to go second quit. Okay. Now our matrix should be stored, and the way we see it is we go back to matrix and we look. Notice in matrix A now we have a 3 by 5 matrix stored in matrix A. So if I just hit enter, it types the name of the matrix on the screen, and if I hit enter again, it puts the matrix itself on the screen, and that's useful. I'm just checking real quickly to make sure that I entered it correctly, and there it is. It's correct. Okay, so how do we get our matrices in reduced row echelon form? Well, go back to matrix, go to math, and go somewhere down the list. There is RREF, row reduced echelon form. Don't bother with REF, do row reduced echelon form, the RREF. And so if I hit enter, it puts it on the screen and it says, okay, what matrix do you want me to put in row reduced echelon form? So it's asking me to go find the matrix name. So I'm going to go back to names. I want matrix A, hit enter, and there it is. I can close that out if I want. So I'm having the calculator put it in row reduced echelon form, and there it is. And you'll notice that it's the same that we found, because remember, when we simplify a matrix to its row reduced echelon form, it will always be the same, provided we did things correctly. All right, it's the simplest version. It's the base level of our matrix. Okay, so there it is. Now we can also do this in GeoGebra. So let's quickly do this in GeoGebra. Nope. I'm going to exit this. And in GeoGebra, you need to get access to the spreadsheet window. So to do that, you go over to View and you make sure you click Spreadsheet, right? So really what you need is the algebra window and the spreadsheet window. And if you click it, it will show that. And you're just going to enter your matrix right here. It's really nice. 1. Let's see. Yeah, okay, so that's going down. 1, 3. Okay, so you enter it, 1, 2, 2. You enter it, I'm hitting enter in between, and so that's moving it down. 1, 0, 4. 1, 5, negative 1. 1, 5, negative 1. And 12, 17, 31. 12, 17. Yeah, just 31. Okay, just real quickly, make sure I've got all the entries correct. Okay, now here's the nice thing. What you do is you just highlight those entries, and you're going to right click, and you're going to go down to create, and you're going to select matrix. And notice it creates a matrix out of that, from that spreadsheet, and you can see it there. It's called M1. And so if you need to manipulate it at all, you are going to use you're going to refer to that matrix as M1. And you could do another matrix right on this same spreadsheet right there, and just as long as you highlight just the entries that of that matrix and create it, it's no problem. It doesn't. We're just using this matrix or this spreadsheet to kind of lay the numbers out, and then we highlight and create our matrices from it, and it would create a matrix M2. Okay, now so how do we reduce this? Put this in row reduced echelon form. So to do this, we just start typing in the command. Don't go away. Come back. In the input, reduced row. So reduced row echelon form is actually the command. So there it is. And now you just want to type in what matrix it is that you're working on. M1. So if you hit enter, there it is, and notice it's the same thing that we've done. So it doesn't give you the steps, of course, but it gives you the reduced matrix.